All right, here we go with Module 2, Lesson 18 problem set. And your objective is that you're going to be able to use the basic math facts to division to find quotients, which are the answers to division problem. And that's going to be the introduction to our long division. So let's go ahead and get started with Lesson 18 in your problem set book. Turn to the page and get ready. And here we go. So the directions say we're going to estimate the quotients for the following problems. The first one's done for us. And so what we're going to do here is we're going to be rounding our numbers to some easy numbers and find some basic math facts. So let's go ahead and start with C. So I'm going to go ahead and zoom in. The rule is when we estimate a division problem, we're going to first estimate the divisor first. Start with that one. That's going to be an easier one to round. 34 is closer to 30, so we're going to put that in the first blank. And then we're going to circle the 3 because that's going to be one of our basic division facts. And then off to the side, we're going to count by 3s. We're going to go 3, 6, 9, 12. And we're going to stop there because what we're going to do is we're going to look at this first digit in the dividend, which is 9,000. If we count by 3s, can we get to 9? Yes, we can. It's going to be 3 times. So that means this number, 9,155, is going to be rounded to 9,000 because we're going to use the basic division fact of 9 divided by 3, which we should know is 3. And then we're going to eliminate 0 and 30, and then we eliminate a 0 in 9,000. So the quotient is going to be 300. Let's move down to F. So we have 2,271 divided by 72. So we're going to round the divisor first. 72 is closer to 70, and we're going to use the 7 as a basic division fact. So let's count by 7s. We got 7. If you double that, that's going to be 14. 7 times 3 is 21, and then 7 times 4 is 28. And we'll stop there. Because what we're going to first look at is the 2 in the thousands place. If you count by 7s, can you get to 2? No, because 7 is too big. But what if we look at the first 2 digits, 22? If we count by 7, can we get close to 22 without going over? Yes, it's going to be 21. So 2,271 is going to be rounded to 2,100 because we have a basic division fact of 21 divided by 7, which is actually 3. So that's going to be our first part of our answer, our quotient. We're going to eliminate a 0 in 70 and eliminate a 0 in 2,100 so that the quotient is now 30. Now moving down to I, let's round our divisor first, which is 89. So that's going to be closer to 90. We're going to use the 9 as our basic math fact. And we're going to count by 9s. We have 9. Then we have 18. Then we have 27. And then 9 times 4 is going to be 36. And let's stop there because let's look at the first digit of 8. If you count by 9s, can you get to 8? Well, you can't because 9's too big. 8 would be over here. So 9 is too big. And so let's go ahead and say, okay, what about 85? Well, looking at what we have here, you know what? 36 is less than 85, but it looks like we can go more. So we're going to continue our multiples of 9. Next is going to be 45. Then it's going to be 54. Then it's going to be 63. Then it's going to be 72. And then it's going to be 81. And then 90. So remember the trick that I taught you guys about the 9s, quickly writing them. If you see the pattern, in the 1s column, you start from 9 and you go all the way down to 0. In the 10 columns, you start at 0 and you go all the way down to 9 and you quickly wrote your 9 multiples. So looking at 85, it looks like the closest I can get is 81. So we're going to round 85,015 to be 8,100 because 81 divided by 9 is a division fact, and that is going to be 9. Eliminate a 0 in 90, eliminate a 0 in 8,100. So our answer is 90. If we drop down to L, we have 93 as our divisor. We're going to round that first, and that's going to be closer to 90. And so what we're going to do is we're going to use all this work that we did up above to help us answer L. I mean, it's kind of pointless to actually rewrite it all over again when you have the work right there. So looking at 4, well, if you look at 4, 9 is too big, so we can't get close to 4. But we can get close to 49, and that would be right here, 45. So this is going to be rounded to 4,500 because 45 divided by 9 is our basic math fact, is going to be 5. Eliminate a 0 in each number, and the quotient is going to be 50. All right, let's move down to L. Let's round 15 first. And 15 is in between, dead smack in the middle of 10 and 20. So the rule is when it's in the middle exactly, you're going to round up. So it's going to be 20. So we're going to use our 2s. We're going to go 2, 4, 6, 8, 10. And let's stop there because I think we're going to be using, since this is 2, we're going to use the 2 in our multiples of 2 to be close to 2,000. Now, you're going to say, well, that's a big jump down to, you know what? Let's do this. You know what? 2,806 is really close to, it's closer to 3,000 than it is to 2,000. So I'm going to erase that 2,000 because the reason why I'm doing this is I think we can actually use some mental math. Let's think about this first. If I circled 3, can you do 3 divided by 2 evenly? No, you can't do that. So what if I did 30? 30 ends in a 0. It's an even number. So whenever you have an even number and you divide by 2, you're going to get an answer. So 30 divided by 2, that cut it in half, that will be 15. And then you can eliminate a 0 in 20 and a 0 in 3,000, and the quotient is 150. So I kind of knew that 30 would work when you divide it by 2 because any even number could divide it by 2. Or what I could have done, even if I knew the even number, I could have done 2,800 divided by 20 because 2 is our even number, and 28 is an even number. So 28 divided by 2, or 28 and half, would have given us 14. And then you cross off the 0 and cross off the 0 there. So the answer, it would have been around 140, 150. So we could have used those two types of problems to solve for O. Moving over to N. Actually, let's go ahead and let's move over to M really quick. We'll skip the N. We'll go to M. Let's round this. 94. That's closer to 90. And let's do our multiples of 9. I'm going to do 0, 9, 1, 8, 2, 7, 3, 6, 4, 5, 5, 4, 6, 3, 7, 2, 8, 1, 9, 0. That's bad 9. Oh, there's our fast multiples of 9 using those patterns that I taught you. So the closest I can get, I can't do 5 because 9 is bigger than 5, but what about 53? The closest I can get without going over is 45. So we're going to use 45. And then it's going to be 4,500. So I'm going to circle the basic math fact, that's the wrong one, of 45 divided by 9. That's going to give us 5. And I'm going to cross off my 0 and 90 and cross off the 0 and 4,500, and the quotient is 50. Let's go up and move up to J. J, we have 68 as our divisor. That's closer to 70 than it is to 60, so we'll use 7. So we'll go 7, we'll do 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. And then 7 times 6 is 42. So it looks like I can't use a 3 because 7 is bigger than the 3. But 39, how close can I get to it? I can get to it using 35. And then add the 2 zeros, so 3,500. Because 35 divided by 7 is a basic math fact, that is going to be 5. Eliminate your 0 and 70 and your 0 and 3,500, so the answer would be about 50. So hopefully you're seeing the patterns here when we're doing estimation. And so let's go over to the next page to tackle some more problems. So number 2 says, a swimming pool requires 672 feet squared of floor space. So let's go ahead and circle that number. The length of the swimming pool, so let's box in the length of the swimming pool, is 32 feet. They want us to estimate, so not find the exact answer, but estimate the width. We're trying to find the width of the swimming pool. So let's kind of just visualize what we're dealing with. We have a swimming pool. I'm assuming it's going to be rectangular because they give us that the floor space, so all of this right here, this space, or we call the area, is, and let's do A equals area, 672 feet squared. Now the length is up on top. We're going to say the length is 32 feet. And they want us to find the width. We don't know what the width is. So going back to 4th grade again, a little quick review. Whenever we want to find the area, A equals area, we take the length and we multiply it by the width. So I'm going to change colors and I'm going to say, okay, well, we already know what the area is. The area is 672. And we do equals, and we do know that the length is 32. So how do we find the width? Well, we can do the opposite of multiplication. We can do division to find out what that question mark is. That question mark is our width, and we could take 672 and we can divide it by 32, and that would give us our width, or that would give us the question mark. But they don't want us to actually find, the exact quotient. They want us to estimate. All right, so we do know that 32 is close to 30. That's our divisor. We round first. We're going to use the basic math fact of 3. And if I did 3, 6, 9, 12, let's stop there. Looking at 672, you know what? It's closer to 6. And so it's going to be closer to 600 for this problem. And then we're going to circle the 3. And then we're going to say, well, 6 divided by 3 is 2. Cross off your 0 on the divisor, cross off 1 0 on the dividend. So it looks like the estimated answer, or the width, is going to be about 20 feet. So let's go ahead and write our sentence out as a statement. So here we go. Here's our sentence that we can write. The width of the pool is, and make sure you have the word about, since we estimated, is about 20 feet. And then we'll go ahead and drop down to another word problem to tackle. All right, let's look at 3. We have Janice bought 28 apps, so let's circle 28 apps, for her phone that altogether uses 1,348 megabytes of space. The question says, if each app So let's go ahead and box in. Each app used the same amount of space. About, that's super important, we're not finding, we're estimating, about how many megabytes of memory did each app use. Show how you estimated. So we're not doing final answers, we're only estimating. So let's go ahead and visualize this with the tape diagram. We're going to say this whole tape diagram represents the 28 apps that she bought. So I'm going to say app number 1, app number 2, ... and then app number 28. So I'm not doing all 28 boxes, but I am showing that by starting with 1 and ending with 28, all of these numbers right here represents from 1 to 28. Now, all of these 28 apps, the space that it takes up on her phone is going to be 1,348, and then it's going to be megabytes. So our job is to figure out what each app uses of megabyte. And they do say same amount. So all of these little boxes would be the same amount of space. So we're actually taking this 1,348 and dividing it evenly into 28 boxes. Remember, they don't want us to find the exact quotient or the exact answer. They want us to do some estimation. So we're going to take the problem here, and then we're going to estimate. So we're going to estimate 28 first because that's our divisor. So 28 is closer to 30. And then 3 is our basic math fact. So if I write actually, you know what? Let's go back up to this first word problem that we did. Here are our 3's. And it looks like I can't get to 1. 3 is too big, but I could possibly get to 13. And look, 12 is close to 13. So let's go ahead and round this to be 1,200. So we have 12 divided by 3. And that's going to be 4. Eliminate your 0 in the divisor and eliminate 1 0 in the dividend. So that means that 40 is going to be the estimated quotient. So that means each app uses about 40 megabytes of memory. So let's write our answer out as a sentence to their question. We can say each app uses, and don't forget about the word about, because that means that we estimated about 40 megabytes of memory. Okay, we'll move that around so you can see that. Remember, hit pause if you need to play a little catch up. So B says, if half of the apps were free and the other half were $1.99 each, about how much did she spend? So once again, we're estimating here. So let's think about this. So half of the apps were free. So if we take 28 and we divide it by 2 and cut it in half, that means 14 were free and 14 that were $1.99. But we don't want to find the exact, put a $sign there, the exact total. They want to know what, about. So if we take the 14 apps, we're going to keep 14 the same because $1.99 is going to be close to $2. And so 14 times 2 ends up being, kind of funny, ends up being $28, kind of like the 28 apps that they have. So she spends about $28 on the 14 apps that she had to pay for. So let's write our sentence out. So you can say she spent about $28 on the 14 paid apps. Go a little more detailed with our answer for the word problem. but make sure the word about is there and you have the dollar sign or the word dollars after 28. And that ends our lesson. Good job. Way to hang through with this. And we're going to go into lesson 19 and start the long division process. Doesn't seem very scary. Some of you are like, long division, oh my gosh, but really it's not. And I'm going to show you some little tricks that might make it a little bit easier when we start doing the division and long division that you might enjoy. So I'll see you on the lesson 19.